Okay, first off, a student asked to see an example of limited infinity involving square roots. So there's a trick you want to use on these. You want to divide everything by the highest power of x. And we want to do that in a fancy way. You're looking at that and you think, oh, well, my highest power of x is x squared, but it's really not because I've got that x squared is underneath the square root. So remember, we're talking limit at infinity. X is really, really big, right? X is like a trillion. X is gigantic. Like a trillion squared times 4 plus 11. That 11 really isn't doing much. And same thing down here. 9 times a trillion plus 2. The 2 is not really doing much. So the end behavior, so as a shortcut, this is just what my mind is thinking. So I want limit as x goes to infinity of root 11 plus 4x squared over 2 plus 9x. All that's going to matter on top and bottom is the leading term, the most important contribution. So this is going to go like, it's going to look like square root of 4x squared over 9x. These guys aren't going to matter when you go toward infinity. So that looks like 2x over 9x. The x's cancel. The limit's going to be 2/9. And I wrote 9/2. Now we'll prove that analytically. We'll go through like a formal way to write that up by dividing everybody by the highest power of x. But that's the answer we're going to get. Now we got to be careful here because I kind of lied right here. Square root of x squared is not x. Square root of x squared is the absolute value of x. But because I was going toward positive infinity, all my x's were positive. So I kind of ignored that fact right here. In this one, we're going to have to worry about that. Okay, so here's how we formally write this up. Limit as x goes to infinity of the square root of 11 plus 4x squared over 2 plus 9x. We're going to divide top and bottom by the highest power of x. And again, the highest power of x is not x squared because that's underneath the square root. This really is an x right here because the square root of x squared. So I'm going to multiply, got to keep writing limit, top and bottom by 1 over x. We're going toward infinity, so I don't have to worry about dividing by 0. Okay, now on the top, there's no equal there. Sorry. Limit as x approaches infinity. On the top, I'm going to rewrite that 1 over x as 1 over the square root of x squared so that I can distribute it inside that radical. I remember when I first learned this, Chris O'Connor showed us this trick and it just blew my mind. I'm like, whoa, where'd you get 1 over x squared? Square root, what? I want to be able to distribute this inside this radical, so it needs to have the same form. Remember, the square root of AB is square root of A times square root of B. You're allowed to separate or combine products of square roots. I am not doing this. Square root of A plus B is not root A plus root B. I'm not distributing a square root over addition. What I'm going to do is take two things that are both square roots and multiply them together by combining the radicals. So this guy needs to be a square root. So 1 over x could be rewritten. Again, we're talking about positive x's here. So square root of x squared. Now, when I distribute top and bottom, I get square root of 11 over x squared plus 4x squared over x squared over 2 over x plus 9x over x. And now I do all my canceling. So here I get 11 over x squared plus 4. The x squareds cancel. Now on the bottom, 2 over x plus 9. Now I take the limit. Remember, limits are linear operators. We're allowed, when we're taking limits, we're allowed to distribute a limit top and bottom, and we're allowed to pass limits inside continuous functions. A square root is a continuous function, so I could rewrite this as limit of the top that's a 4 over limit of the bottom, provided both limits exist. I'm only allowed to do that step if both limits exist and are finite. But you'll see they are. And then again, I'm allowed to, because the square root is a continuous function, pass that limit inside. So here I get square root of the limit of this stuff. And then bottom, I'm taking the limit as x goes to infinity of the, I really should have parentheses here. Okay, now what do all these limits do? Anything that's got an x in the denominator is going to go to 0. 11 over x squared, as x goes to infinity, that goes to 0. This 2 over x goes to 0. So now I've taken the limit. The limit as x goes to infinity of 4 is just 4. The limit of a constant is that constant. Limit as x goes to infinity of 9 is just 9. So I get square root of 4 over 9, which is 2 9ths. Okay. Now, the exact same game here, but now I've got to be concerned. I'm plugging in negative x values. So we know we're going to have the same basic process, only the bottom is going to stay negative, whereas square root always spits out positive numbers. The top will always be positive. No matter what x values you plug in, square root never spits out negative numbers, whereas the bottom will be negative. So we get the same answer, but a negative number. Okay. Remember, we can use this same trick on polynomials. If I wanted the limit as x goes to, say, positive infinity of 9x to the 5th plus 3x minus 2 divided by 4x to the 5th plus 8x squared plus 10,000x. So we've got some rational function here, polynomial over polynomial. We divide everybody by the highest power of x. The highest power of x here is x to the 5th. So what I'm doing here is multiplying top and bottom by 1 over x to the 5th. And I'm going to skip the work. Yeah, maybe I better write it out. So divide everybody top and bottom by x to the 5th. And then we do all of our canceling. These cancel completely. These guys will still have x's in denominators. So we get 9 plus 3 over x to the 4th minus 2 over x to the 5th. 4, 8 over, what we got there, x cubed, and then 10,000 over x to the 4th. Anybody that has an x left in the denominator, when we take the limit, again, if I were writing this out formally, I would take limit of top over limit of the bottom. Then we can distribute the limit. Remember, you're only allowed to do that provided both limits, top and bottom, exist. And in this case, they do. But everybody here that's got x's left in them, these are all going to go to 0 as x goes to positive infinity. And we just get 9/4. So that's that trick we learned when we're looking at a rational function. Like you learned this back in college algebra. If you have the same degree, top and bottom, you don't have to go through any of that work. Like the answer is right in front of you. You just take the ratio of leading coefficients. If the bottom's bigger, if this had been 15 down here, then the whole thing's going to go to 0 because we would have divided everybody by x to the 15th. That would be our biggest. And this guy would have gone to 0. If the top's bigger, say that's a 25 now, we divide everybody by x to the 25th, well, then you're going to end up with the bottom going to 0 and the top not. You either get infinity or negative infinity. Okay, I hope that helps. All right, let's do some questions that might be on your test 1. So you got practice test 1 coming up. Like I already showed you where my solutions are here, both in PDF form and a video. Highly recommend watching my video, going through all these solutions. These are all good questions. Say, hey, look at all these. We're taking a bunch of limits. That one is a limit as x goes to infinity. These are just finite limits here. Here you got to use those other tricks. That game of dividing everybody, that only works when you're taking a limit as x goes to infinity. Make sure you know how to do this one. All right, questions like this. I'm going to make up a new problem like this. Like I'm telling you ahead of time, you're going to have a question like this on the test. So here, let's make one up. So let's say we've got, I don't know, maybe cx plus 8 for x less than 1. Maybe x squared plus 2, x greater than 1. Here, I want to do 3 pieces. So let's say 1 to 4. And then, I don't know, negative 3x plus d for x greater than or equal to 4. I hope I just made this up. So let's hope I made up numbers so that this is even possible. Like I guess we'll adjust if I didn't, right? I want to find values of c and d so that the function is continuous everywhere. When we say a function is continuous, we mean continuous on its domain. And the domain here is all real numbers. So I need the pieces to match up. I need this line to intersect this quadratic at that cutoff point there at 1. So what I need is the limit as x approaches 1 from the left, which is this top piece, that's when x is less than 1, to equal the limit as x approaches 1 from the right. That will be this piece coming from above. So the limit as x approaches 1 from the left, that means use this piece. And this is everything I'm writing out is required for a complete solution. You have to write this. This is what I'll be grading. Did you write this line here? So that there will be c times negative 1 plus 8. So this function is just a line. It's a polynomial. Polynomials are continuous. limits are the function values. Now, I know he's not defined at 1, this guy here, but if he were defined, that would be equal to his limit. And same game here. The limit as x approaches 1 from above, so we want numbers just a little bigger than x, and we're taking the limit as x gets closer to 1 of this guy. He's a polynomial. How do you find his limit? By plugging in. So we plug in 1. So what do we get here? We get negative c plus 8 equals, what is that, 3? So negative c is negative 5. I think we get c equals 5. All right, so now we have forced these two pieces to match up at that boundary point 1. Now we need these two pieces to match up at 4. So we want the limit as x approaches 4 from the left, that will be the quadratic, to equal the limit as x approaches 4 from the right. That'll be this guy here. And how do we find those limits? Just by plugging in. So that's what we're always doing. We're plugging in these endpoints into two adjacent functions. But we have to write this out. Like this is required for a complete solution. So what do we get? 16 plus 2 equals negative 12 plus d. Plugging in 4 to both of those. 18 equals negative 12 plus d. What is that, 30? 28 to... Guess I'll have to check my arithmetic, but I think that's what we get. So that's a complete solution. That's what your solution will look like. Make sure you know how to do those. Practice a few. You got some in the homework. Remember, there's also, besides this document, this review assignment that you can do as many times as you want. You can do this over and over again. Every question that's in the pool of questions, or every question that's actually on the test, exists in the pool. So theoretically, if you do this enough times, you'll see every possible test question. Remember, this closes before the test opens, though. Okay. Using the definition of the limit. Okay. Now, everybody, make sure you're listening to my words right here. We have not learned power rule yet. We've not learned product rule, quotient rule. We have not learned all these fancy ways to take derivatives. You may know that stuff already. Maybe you learned this in high school. Maybe you've watched ahead a little bit. Maybe if I give you the function, let's say 5x squared minus 3x plus 2, maybe you can just do the derivative in your head. That's not what I'm testing on test 1. I'm testing if you can find the derivative using the definition of the derivative. So in every question that asks for a derivative, you are expected to use the definition. That's what I'm testing you on. So you're going to, remember, you got 5 problems where you got to show your work. A few of them, you're going to have to use the definition of the derivative to find the derivative. The question may not say that. The question may just say, find the derivative. So it may not explicitly say you have to use the limit of the difference quotient. The reason I didn't put that in there is because there are people that are not listening to my words right now. They're not even watching this video. They're going to take every single question and they're going to submit it to Chegg. It's going to happen. And then the Chegg tutor, I shouldn't even call him tutor, the Chegg cheater is going to look at that, and the question doesn't say use the definition, so they're just going to use power rule, and they're just going to write down f prime of x is 10x minus 3. You should just power rule, right? You can just do it in your head. Well, now that student's going to turn that in. Then I'm going to have a Zoom meeting with that student, and I'm going to say, I told you in the Zoom meeting, this one we're talking about right now, I told you you had to use the definition of the derivative. How'd you get this? And that student's not even going to know how they got here because you guys are all paying attention. You're listening. You're not going to do this. You're not going to just submit this to Chegg and copy some answer you don't even understand. And then that student's going to get an F in the course. Now, let's say that happens the other way. Let's say maybe you are listening and you just forgot, but you've been watching ahead. You know power rule, you know chain rule, you know all of that. You know how to do this. We have that Zoom meeting, and I say, "How'd you get from here to here?" And you go, "Oh, come on, it's easy. It's power rule. 2 times 5 is 10. Power drop. Like you know what you're doing. What the? Then you didn't cheat. Like I'm still going to take points off because you didn't follow directions, but you're not in trouble. I'm just letting you know, I highly expect that somebody will get caught cheating on test one from this right here. Every question on test one, I want you to use the difference quotient, the limit definition of the derivative. That's what this test is about. I know there are techniques you can use to do, there are shortcuts. I don't want you to use those yet. You'll be able to use those later. Okay, I hope that makes sense. All right, so let's find the derivative. And then we'll find, so maybe like maybe that's part A. Part B, we'll find the equation of the tangent line. That means equation right there, EQ apostrophe N. At, oh, I don't know, maybe X equals 2. All right, then F prime of X is by definition the limit as H approaches 0 of F of X plus H minus F of X all over H. You need to have that memorized. Okay, so let's fill that all in. F of X plus H means rewrite the function, but now instead of writing X, write X plus H, but rewrite the entire function. So that right there is F of X plus H. From that, I subtract the original in parentheses, and that's all over H. We're going to have over H until the second to last step. All right, now we clean everything up. So X plus H squared, you should have done so many of those recently that you just know that that's X squared plus 2XH plus H squared. Almost lost squared there. Let's distribute everything else. Distribute that minus over H. Don't forget your over H here. Distribute that 5. Yes, this is a lot of writing, but come on, it's not really that much, is it? And then if you know all the shortcuts for finding derivatives, you should easily be able to check your answer. But this is honestly, this is just basic algebra mostly here. All right, everything after that minus sign right there should cancel out. If it doesn't, you've done goofed somewhere. Everything that's left over, what am I writing? What am I doing here? I got used to from that other problem earlier, writing X goes to infinity. It says H goes to 0. Limit is H goes to 0. I apologize. Okay. After those cancel out, everything that's left over should have an h in it. If something is left over that does not have an h in it, you've done goofed. Because that's our next step here. Factor out the common factor of h. Then the h's cancel. You can't cancel until you factor out. You cannot cancel these h's. Common mistake there. Now we can actually take the limit by plugging in h equals 0. So I'm not going to write limit anymore. And we get 10x minus 3. Exactly what we knew we were going to get. If we know power rule. Now, remember, you have to write up complete solutions. There were probably a couple of steps here you could have skipped. Like maybe you jump straight from here to here. Or maybe you didn't write this out. You just started going here. Like maybe you skip a step or two in this process. I understand that. That's fine. Mostly though, what you see in front of you is what's required for a complete solution. And remember, you got to write limit as h goes to 0 at every step until you actually take the limit. We don't write limit anymore because now we've taken the limit. As soon as you're plugging in h equals 0, you've taken the limit. All right, so that's my derivative. All right, now I wanted the equation of the tangent line at 2. So my function was 5x squared minus 3x plus 2. So the equation of the tangent line in point slope form looks like this. We're going to need this in slope intercept form though, so I'm going to have to do some extra work in a minute. X naught, I know. We want the equation at 2. So that's 2. How do I find that guy? I plug 2 into the original. That's f of 2, which will be, let's see, that's 420 minus 6 plus 2. So 22 minus 6, I think we get 16. Okay, what about m? Right there. That's the derivative at 2. So I'm going to plug this x value they gave me into both the original to get my new y value and the derivative to get my slope. That's what derivatives do. They spit out slopes of tangent lines. So f prime at 2 will be 20 minus 3, 17. So then my equation will be y minus 16 is 17x minus 2. And that's in point slope form. What if I want this in slope intercept form? Then I've got to distribute here, 17x minus 34, move the 16 over. -18, -18. I think definitely check my arithmetic there, but we're really talking about process today. So you might have a question that asks for m equals blank, b equals blank, 17, -18. Like I'm kind of telling you ahead of time here. Okay, now I want to practice just a couple more definition of the derivative problems. Let's say we had, I don't know, 2 over x minus 1. This is going to be a nasty, ugly one. Let's find, using the definition of the derivative. So I want limit. See, I almost wrote it again. Limit as h goes to 0. F of x plus h minus f of x all over h. So f prime equals All right, f of x plus h means rewrite this guy, but put x plus h in for every x minus the original all over h. Okay, now we got to use a trick. I've got to somehow combine these fractions together. And I do that by finding the common denominator. Remember, like I'm going to teach you a trick here. I don't know if anybody's ever taught you this. If you're adding or subtracting fractions, say you've got a over b minus c over d. There's this like cross multiplying kind of trick you can use that always works. You multiply up like this, a times d. Keep that sign, whatever it is, multiply up like this, b times c, and that will all be over these guys multiplied, bd. So say, I don't know, I had 2/3 minus 1/4. Multiply up 8 minus, because that's a minus, 3 over 3 times 4 is 12. So 5/12. It's a quick way to add or subtract fractions. I'm going to do the same game here. My LCD would be this times this. So this guy here, top and bottom, needs an x minus 1. That's the same as taking this and multiplying it up here. Minus, because that's a minus. This fraction needs an x plus h minus 1 top and bottom. So that's taking this and multiplying it up here. All over these guys multiplied together. And I do need parentheses here. Okay, now we're going to clean up that top. Limit as h goes to 0. What do we get? 2x minus 2 minus 2x. I've got to distribute that negative there. Minus 2h plus 2. All over all this stuff. 2x's cancels. The 2's cancel. So we get limit as h goes to 0. Oh, wait a minute. Hold on. Something canceled that should not have. Let me pause a second. Okay. Something wasn't working out, and I realized there has to be a mistake somewhere. And I made the fundamental error, the one that a lot of students make. This is supposed to be over h. I dropped my over h. Maybe I did this on purpose to see if you were paying attention. You don't know. This is all over h. All the way down over h. So what do we get here? We get negative 2h left on top over x plus h minus 1, x minus 1, all over big fraction bar h. Now let's think of this because it makes the arithmetic a little easier. Think of that as h over 1. So this is a fraction divided by a fraction. This is my big fraction bar here. So we do some keep, change, flip. What's going to happen is the h is going to cancel. So I get negative 2h over x plus h minus 1, x minus 1 times. So we had fraction divided by fraction, keep, change to multiply, flip this guy over. H's cancel, then I can take the limit. So let's write what's left, and then I'll take the limit. Now that the h's cancel, I can take the limit by plugging in h equals 0. Remember, if somebody hands you a function and says find a limit, first thing you try is plug it in. Any step up here, if you plug in h equals 0, you'll get 0 over 0. If you get 0 over 0, that means you got more work to do. It means you got to cancel out the thing that's giving you 0. Now that we've canceled it out, I can try plugging in h equals 0 again. I will not get 0 over 0. I'll get this. That h is 0. This becomes x minus 1 times another x minus 1. That's x minus 1 squared. So this guy's derivative is this. Okay, and let's do one more. This be it for today. Let's do a square root. So why not? Let's make it nasty. Let's find this guy's derivative. Like this is probably the worst problem you can do using the definition of the derivative. This is like as bad as it gets. So we want limit as h goes to 0 of f of x plus h minus f of x all over h. Limit as h goes to 0. Replace all the x's with x plus h in parentheses. Minus the original f of x all over h. Okay, on these, what we have to do is multiply the top and bottom by the conjugate of this guy. So we're going to multiply by something that looks exactly like the top, but we're going to change that to a plus. So we're going to have a limit as h goes to 0. I'm going to go ahead and clean this up. So what do we got there? 3x plus 3h plus 1. Times, and then I need parentheses here. Top and bottom, the exact same thing. But now I want a plus in between the radicals. And if I do that on the top, I have to also do it on the bottom. Okay, now let's distribute top and bottom, or distribute on the top. Leave the bottom alone. What's going to happen? The reason we use the conjugate, our middle terms are going to cancel out. This is the difference of squares formula. So we're going to have these guys multiplied. Outer and inner will cancel out because I have conjugates here. This minus this will cancel out. So what you end up getting is this first one, and that's just this thing times itself. Square root of a times square root of a is just a, because it's square root of a squared, which is technically absolute value of a. But we don't have to worry about that here. We're just going to get a. So this guy times this guy, don't forget to write limit, is just going to be 3x plus 3h plus 1. Again, outer minus inner, or plus inner, but inner is negative. Those will cancel out. And then we get last, FOIL. That's all I'm doing, FOIL. I'm going to get a minus because one of these is negative. I get square root of junk times square root of junk. That's just junk. And I need to put this in parentheses. And I'm going to leave this bottom the way it looks. Okay, I'm going to distribute. Remember, our goal here is to plug in h equals 0. If I could just plug in h equals 0, I would be done. But if you try that, you're going to get 0 over 0. So here, this negative will distribute. I'll get negative 3x minus 1. 3x, negative 3x cancels. 1, negative 1 cancels. I get 3h over all this stuff in the bottom. Hey, look, the h's cancel. That's what's going to happen on every single definition of the derivative. At some point, next to last step, your h is going to cancel. Now you can take the limit by plugging in h equals 0. So don't write limit anymore. I am now taking the limit. So I'm going to replace, I'll actually write it out. I'm going to replace all of my x's with 0, or all of my h's with 0. That's a 3 right there. Let me make that prettier. We're replacing h with 0. So what do we get here? I get root 3x plus 3. 3 times 0 being 0 plus 1. So 3x plus 1 plus another one of the same thing. I can combine those together. That's just 3 over 2 root 3x plus 1. And that is my derivative. We have not learned chain rule yet. We've not learned quotient rule. We've not learned any other rule that would allow you to get this. So if you had this question on your test and you don't do it using the definition of the derivative, I'm going to be suspicious and we're going to have a meeting. Don't cheat in my class. All right, any questions from anyone that's here? Anything else you would like to see? Nothing? All right, let's stop the recording.